Here we are going to consider the class of simultaneous equations or types of simultaneous equations. Before that, I am going to represent the linear equation in two variable as a straight line. Now we can consider the classification of simultaneous equations or types of the simultaneous equations. Note that the linear equation in two variables represents a straight line in a plane. So substantiate this, we will consider let us consider linear equation 2x plus y minus 1 is equal to 0, and the table for the various values of x and y. X and the corresponding value of y in the following table. We can see here x is equal to minus 1, y is going to be 3, x is equal to 0, y is equal to 1, x is equal to 1 and y equal to minus 1, x is equal to 2, y is equal to minus 3. Plot these points in the table given by the pair xy in the coordinate plane at the right hand side figure. Here we are considering the coordinate axis xo x dash and y dash, and we have demarcated the units 1, 2, 3, 4, 5, etc. Minus 1, minus 2, minus 3, so on and so forth. Similarly on y-axis also. With the help of this coordinate axis, we can plot the points here as per the table. Minus 1 and 3 here, minus 1 and 3 here, here you can see here minus 1 and 3, and 0 and 1 here, and this is 0 and 1 here, and 1 and minus 1 here, and 2 and minus 3 here we can consider, and thereby we have plotted the points, and you can join these by straight line, or use straight line, draw the straight line passing through these points, so we can have this straight line, and these straight line points on this straight line satisfy the equation, and moreover you need not take 4 points here, 4 values, just 2 values, so we can identify 2 points, and by Euclidean idea there passes one and only one straight line through 2 points. This how we can represent a linear equation in two variable with in two variable, and this equation represents a straight line. My aim is to show that the linear equation in two variable always represents a straight line. With this idea in mind, that is, any linear equation in two variable can be represented by a straight line, or we can say any straight line in the plane can be written in the terms of algebra using two variables, a linear equation in two variable. Keeping this in mind, I am going to take some examples, a pair of some linear equation in two variables. Look at these examples. 2x plus y minus 1 is equal to 0, and x minus y minus 2 is equal to 0. And these two linear equations, I am consider the table in accordance with the equations mentioned here. And the table two tables, 2x plus y minus 1 is equal to 0. For that, x is equal to 0, y is equal to 1, and x is equal to 2, y equal to minus 3. And similarly, in the second case, x minus y minus 2 is equal to 0. Here, x is equal to 0, y equal to minus 2, and x is equal to 2, y is equal to 0. With the help of this table, let us plot the point in the right hand side coordinate axis, which I have depicted here. And now we can plot the point here accordingly, according to the table given here. The first one is 0, 1, and 2 and minus 0, 1 from the first table, and 2 and minus 3 for the second table, first table itself. And from the second, 0 and minus 2, and 2 and 0 here on these 4 points have been plotted on the coordinate axis. With this, we can see here points, the points, we can see the points, and also draw the lines accordingly. And therefore, you can consider another, the point of intersection here is 1 and minus 1. That is going to be the solution of these two simultaneous equations. 1 and minus 1 satisfy simultaneously of the given two equations. Second example I have given here, and in the similar fashion we can have a table of values for x and y in the same fashion. For this also we are going to consider coordinate axis as above, and with this I am going to plot the points as well as draw the lines accordingly. Here you can see first one, this one, that is I can write down here first one, that is 2x plus y minus 1 equal to 0, and the second one 4x plus 2y minus 8 equal to 0. These two represents a pair of equation given by two pair of linear equation in two variable. In the above case, this equation, the first one represents 2x plus y minus 1 is equal to 0, and this is x minus y minus 2 is equal to 0. They are intersecting at this point 1 and minus 1. And what happens we will see in the next example, end of the next example. Consider the third example, 2x plus y minus 1 is equal to 0, 4x plus 2y minus 2 is equal to 0. We will have a table for these two equations, and along with the coordinate axis as here, 2x plus y minus 1 is equal to 0, x is equal to 0, y equal to 1, x is equal to 1, and y is equal to minus 1. Second equation, 4x plus 2y minus 2 is equal to 0, x is equal to 1, and y equal to minus 1, x equal to 2, y is equal to minus 1, minus 3. On this one, we can depict the points as well as we can draw the straight line on this one. And for the second equation, we can have a straight line here, points I have drawn, and this second equation also we have written, and on the, what you can say, green line we can say. And now we can see here these lie on one another, and therefore we can see this we can see, observing these what you can say, four pair of equations. In case of one, we can see 2 by 4 equal to 1 by 2. Sorry, this is not 1. 2 by 1 in the first pair of equation is not equal to 1 by minus 1. In this case, the pair of lines, they are intersecting at 1 and minus 1. And that is going to be the solution for the pair of equation which satisfies simultaneously. The second one, in the second equation, what is that? 2 by 4 equal to 1 by 2 is not equal to the ratio of constants, who can say minus 1 by minus 8. Here, two straight lines represented by the equations are parallel. Hence, no solution. Solution exists. In the third example, we can see here 2 by 4 equal to 1 by 2 equal to minus 1 by minus 2. In the third example, look at the graph which you have written here. The two straight lines lie on one another. And here there are many solutions. I mean, any point AB on one line satisfy by the other equation, other line, or lie on any point AB lie on one equation, lie on one line, satisfy the other line. I mean, lie on other line also. Lie on the other line also. And hence, infinite number of solutions. For this pair of equations, solutions. And therefore, we have these particular examples. We have seen the properties based on the ratio of the coefficients of x and coefficients of y, and also the constant terms, and therefore we have general, instead of particular examples taken above 1, 2, 3, we consider standard form of simultaneous equations, and on the basis of what you can say ratio of the x and ratio of the coefficient of the ratio of x and coefficient of the ratio of y and the constant terms. Depending on the ratio, we are going to classify the set of a pair of linear equation in two variables that we would like to write down here. A1x plus b1y plus c1 is equal to 0. A2x plus b2y plus c2 is equal to 0. And one is a1 by a2 is not equal to b1 by b2. Then we say that the equations are consistent and have a unique solution. I mean, one and only one solution. In the second case, a1 by a2 is equal to b1 by b2, but C1 by C2 is not equal to either of these two ratios. Then we say that the equations are inconsistent and has no solution because they represent a parallel straight line. And the third one, ratios of x and y and also the constant terms, they're all equal. Then here also equations are consistent. Be consistent means having a solution and infinitely many solutions because they merge on one another, and therefore this way we can classify the pair of linear equation in two variables or simultaneous equation into three categories. Categories 1, having a unique solution. Category 2, don't have a solution. And category 3, infinitely many number of solutions.